So here we're going to find the length of the curve, the cube root of x from 0 to 4. So cube root of x looks something like this. Going from negative infinity up to positive infinity. We want to figure out from 0 to 4, so from 0 to 4, the length of that curve there. So to do this, we use our formula, integral from a to b, square root 1 plus the derivative squared dx, provided the derivative is continuous on the interval a to b. So here a is 0, b is 4, f of x is x to the 1/3, which is, x to the 2/3. Oh, wait, golly, I'll get this right in a second. So square root has an index of 2 here, so 3 over 2, so 3/2 would be that exponent there. So the derivative, f prime of x, power rule, bring the 3/2 out front and subtract 1 from that, and it gets me to the 1/2 there. So this is 3/2 square root x is my derivative. So whenever I plug this in, integral from 0 to 4, square root of 1 plus 3 over 2 square root of x squared dx. So what I'm looking for you to do some algebra here. So simplify this. So I have 1 plus, now 3 over 2 square root x times 3 over 2 square root x. That's what happens when you square it. Square root of x just makes x. And 3 times 3 is 9. 2 times 2 is 4. Okay, dx here. All right, so that's simple enough. You can do this one of two ways. You can either just do it by hand, or you can do it with a calculator. Doing it by hand, I'd do a u substitution. U equals 1 plus 9 over 4x. du is 9 over 4 dx. So to get rid of the 9 over 4, I do 4 over 9 on both sides. If I multiply by 4 over 9, I get 4 over 9 du equals dx. And so I'm going to replace the dx here with the 4 over 9 du. I'm going to replace this piece with my u. I'll leave my bounds blank right now because remember here they're in terms of x. Okay. Now technically if I did make them in terms of u, well, what is it? When u equals 1 plus 9 over 4x, well, what is x here? It's 0, so that would be a 1. And then u equals 1 plus 9 over 4. And then here I have a 4, and so that gives me 1 plus 9, which is 10. So this goes from 1 to 10 now. So this is 4 over 9, integral 1 to 10, u to the 1/2 du. Integrate, I get u to the 3/2, 2/3 here, and multiplied by 4 over 9, evaluated from 1 to 10. So this is 8 over 27, and then 10 to the 3/2 minus 1 to the 3/2, which is 8 over 27 times 10 root 10 minus 1, or roughly 9.073. Okay, now how do we do this in a calculator? So type this in a calculator, this piece up here, 0 to 4 square root 1 plus 9 over 4 x dx. So I'm going to go here and I'm going to hit math and 9. I'm going to go from 0 to 4 of what? Well, it's going to be 1 plus 9 over 4 x And all of this is in the square root, so I'm going to do square root here. Oh, do I have to retype this? Okay. Let me just start that over. All right. So let's do math 9, 0 to 4. Inside my square root, I have 1 plus 9 over 4x. And I get 9.073. Okay? So not too bad. Now, sometimes the curve is not defined as y as a function of x. Sometimes it's defined as a curve is x as a function of y. Okay, so x as a function of y. So instead of y equals f of x, it's x equals g of y maybe. For some c to y to d. So y is stuck between c and d. And the derivative excuse me, of g is continuous on this interval. Okay, so then if that's the case, the integral, the length is equal to the integral from c to d of the square root of 1 plus g prime of y squared dy. Okay? So let's do a problem. So I want to find the length of the arc of the parabola x equals y squared from 0, 0 to 25, 5. Okay? So I want to find this length. Now, I always like to draw my picture, kind of give me an idea here. Remember, if I had y equals x squared, that'd be a parabola like this. Okay? But that's y equal x squared. What am I doing? I'm swapping my x and my y axis here. So the x and the y axis get swapped. If I swap that, what happens? It looks like this. So this is x equals y squared. And what do I want? From 0, 0 to 25, 5. So I want to know how long that curve is right there. So 25 here and 5 there. All right, so how do I do this? Well, I have g of y equals y squared. So g prime of y is 2y. Okay. I'm integrating from y equals 0 to y equal 5. So the integral c to d, square root 1 plus g prime squared dy. So this is equal to the integral 0 to 5, square root 1 plus 2y squared dy. Simplified. So all you need to do is just simplify, and then you can put it in your calculator. So I want to see the picture. I want to see your formula, and then that's simplified, and now you can solve. Now, if you wanted to, you could use trig substitution to do this by hand, but if you have a calculator, why bother, right? So calculator says math 9, 0 to 5 square root 1 plus 4. Now, I see that I have a dx already in my calculator, so as long as you just use the same variable, it's okay. Okay, so don't get too caught up on, oh no, it's supposed to be y there. But but you can see that that x is already built in there, so that's why I use that there. So I get 25.874, okay? And that happens to be the answer. So TI-84 calculator, hit the math button, then hit 9 for the integration function. And you type in, you know, with the older version, it might look something like this. And then there's like a blank here. And you would type in your function. You do squirt 1 plus 4y squared. And then you put a comma. And then you put your variable. If you use y, put a y there. See, I used y here, so that's why I put the variable there. Then you put your lower limit and your upper limit, and then you close it. So let me write that out for you. This is your function, and then you put a comma. Sorry. And this is your variable, whichever variable, dummy variable you decide to use, comma, lower limit, comma, upper limit, and then you close the parentheses there, okay? And you hit enter, and you should get that. And so that's with the older version. If you got the newer version, you know, to give you that pretty little integral sign that my calculator showed you.